My name's Dr. Michelle Ellis. I work here at Edith Cowan University here in Perth, WA. My role here is to promote digital technologies to our high school students. The workshops that we do mostly is on digital technologies, using our website as a platform to teach kids how to use Python and on a microbit to be creative and innovative. So what we did was that we set up a makerspace.ecu website, and the front page looks something like this. This one here takes you into some teaching resources. This one here takes you to a Discord if you want to have communications with us. And this one here takes you to the coding platform. So on the coding platform, we went ahead and bought a whole lot of Grove kits. So they've got buttons, joysticks, sound sensors, moisture sensors, a weather, sunlight, ultrasonic, vibration, servos, and motor drivers. So with these, what we wanted to do was that our software engineer went through and put this into Blockly code, made it a bit colourful. And so that means that when you click on the code that you want, you also get the Python code that sits alongside it. And again, this was something that I sort of saw as being a way in which we could sort of bring coding more back into the classrooms and back into the students. So what we've done is that we made some lesson plans that went along with the different activities. So, for example, if you're in year 7 and 8, these are some activities that you can access. And so, for example, you can do it in Python code, because one of the school groups that I've been working with now, they're sort of like moving away from the Blockly coding, and they want to just, do the Python coding with some of their kids. Some of the beginning kids who are still in that Blockly stage, then they can access that as well. So if we have a look at the distance sensor, and I'll do it in the Blockly code first. So Mark is the one who's put this together, and we tried to link it to the curriculum. We tried to give a little bit of a story about how distance sensors actually work as well. My attempt at doing data flow diagrams, so that, again, just to get the kids sort of like starting to focus about, coding is a process, there is an algorithm, and that you have to make things happen. It's not just like, throw in and copy and paste sort of stuff. Because we're using breadboards, there's a little bit of electronics that goes along with it, and it just goes in there and gives them a little bit of an explanation of the different theoretical components. So it's kind of like that they should be able to, take this on board and do it themselves. For some kids, they will just go straight to the last page and just copy the code. So, and not really pay much attention to it, but depending on the teacher and what they want to do as well, then they can start pulling out, and let's have a look at the X and Y axes, let's have a look at the mathematics that goes along with this, and how do we do these calculations. So again, it's up to the teacher's kind of abilities as well as what they can and can't do. So this is what it sort of looks like when it's all together. So you've got the microbit, you've got the header, you've got the wires that goes into the distance sensor. And then when they've done that, they can also then add a buzzer onto it as well. So that means as the sensor comes closer to the equipment, as your hand comes closer to the sensor, then a buzzer will go off as well, instead of just lighting up the microbit. So that's what we wanted to do there. So what we have is that, so Glenn is very good in that he's just made these tabs. He's put shadow blocks in it as well. So I'll run through this. It's just got some basic elements for kids to actually be able to do, and then with the microbit, then they can go in, and again, it gives you some functionality about what to do with the microbit. Previously, what we were doing was like, this is what an accelerometer is, this is how it works, and we would do a fun activity with that, or we would do something with the compass and, the buttons. So we're changing the inputs, looking at what are the outputs and things like that as well. Radio communication, which is great fun as well. If we go, for example, scroll message, and you want it to loop forever, then all these blocks just lock in. Then you can teach them about how, that this is 0, this is 1, this is 2, this is 3, this is 4. So depending on the capabilities of the teachers and where they're at with their thinking is what they can actually start to teach. And depending on where the kids are at and what they're capable of, this is, something that they can access as well. So they can code in PyBlockly, or if they don't want to do it that way, they can just toggle this one here and then they can code completely in Python. And this is what we were doing the other day. With this particular website, like it's free and it's available. We run it out of here. We haven't got anything sitting behind it yet, and the intention is one day to collect data on it, but we haven't. There's only Glenn and myself who are, working on this. At the moment, we were just keen in getting it up and running over the last couple of years and getting schools to know that it's available. It's a nice sort of conduit, depending on where you are with your Grok learning, as to what you want to do next. If you've got microbits and the like as well, then, you can, again, show the kids what the capabilities are and then ask them to look at how that they can design their own sort of projects and be innovative. So with this website, for example, we can change the background depending on your sensitivities. If you want to, you can go to the reference page so you can find out a little bit about how does the accelerometer work. And here is the accelerometer, and there's obviously some code that goes along with it about how to use it. You can also, like I said, you can toggle it so that you just code straight into Python. We had a group of students that were on Tuesday coding, and we just went, no, we're going to go straight into Python, and that's why we're going to use it for the microbits. And they just made all kinds of gadgets that flashed and lit and made noises and things like that. You can download the Python to your USB. You can change the zoom side, and the other tricky little bit is that you do have to update the microbit to this website because of the different configuration sitting in the back, and this is already set up for you as well about how to do the maintenance on it, and then just to flash it, and then you should be good to go again. So yeah, so you can zoom on both sides, and then I can actually take that back down to being a bit normal. So it's quite user-friendly. It's quite accessible. I think that you can have lots of fun, using it. You can start to extend what they want to do by adding on the other sensors as well, and creating some really cool lessons, and hopefully inspiring them to go further and to do some of their own thinking, their own innovation. So I'm just showing you the moisture sensor again. So on these lesson plans, it also tells you about how to get started, to make sure that you can, Google Chrome is the one that we have to use, that when you get on there, just put in the scroll message and then make sure that your computer can communicate with the microbit. So here's how you compare it. If it doesn't work, then this is what you need to do with the troubleshooting, which is the firmware guide as well. And then it gets into the activity. One of the things that we did do the other day as well was the make code projects. So again, what we did was that we after we introduced the students to our website and how to code, we said, look, there's some really cool sort of projects. If you want to have a look at what you can do, just click on the Python. We took them through the beginning aspect of it. So, for example, a beating heart shows you how to do it, gives you the code. And so, yeah, they just, you had a look what's on there. Then they just went on to the into the Python, and then they just loaded whatever they wanted to make from that site and downloaded it to our website as well. For me, it's about making coding come to life, making teachers feeling a little bit more comfortable with it. As a teacher, if you've got beginner coders, so Warwick Senior High School, I've been working with them. There's a group of kids that are still at this sort of stage, and other kids that are sort of like wanting to get into the Python and get moving along with it all. And I just sit in the background and just give them a couple of, hints about, what needs to be done or what troubleshoots and problems and the like as well. I think this is where the part that for schools is that you can start to have a look at, this is how it works right now. Go and have a look at how it works in the real world and just be really funky with it. Yeah, and I think for me, my experiences with the the teachers and that sort of as well is that you have those ones who've got the digital technology, computer science backgrounds, and then you've got others who are like the other I met the other day. I'm a phys ed teacher now. I'm doing teaching computer science at one of our local schools, and she's going to do a whole week at She Codes to learn how to code in Python. And it's just like, well, look, here are some resources that you can use that can help you, but help the kids as well. What we want to do is digital technologies to be promoted, to be taught well in our schools, so that we can actually fill the gap in the workforce and also with women in the field.